So in the previous video we actually stopped here. We have derived this dude over here. Okay, this is the stiffness matrix for the beam, the general equation. Alright, and if you just to remind you is that we derive it from the PVD, principle of the virtual displacement. Alright, just take note of it. Alright, so therefore let's continue. Alright, let's evaluate this B so that we can derive certain stuff, because we know that using this thing you can derive your stiffness matrix. Alright, where objectives, just to show you the objective, we are there. Alright, where we are near there already. This is to derive that. In this video we're gonna derive that. Alright, unlike the bar one is k equals to a over l and then 1 minus 1 minus 1 1. In this case it's this one for the beam. Okay, so let's start. Same thing, if you were to watch back, I highly suggest that you watch back my video on the whole lesson 8. Alright, all this video, about 12 videos. I know it's kind of long, but I highly suggest you watch it. So later on, because I'll just skip quite a lot of stuff. But anyway, I'll just go on with this first. If you don't understand what I mean later on, then you'll just watch back the previous 12 videos. Alright, but let's continue. Alright, so the b itself is in terms of d2n dx square. Alright, so we can actually do in terms of a chain rule type of stuff. So d2n dc square, alright, dc square over dx, dx1 square. So is it? Yeah, so if I were to cancel, because this is dc square, I'll just cancel. I'll have this d2n over dx1 square. This is one. Okay, so be kind of careful of doing that. Alright, and also be very careful that this thing, I think this is a good reminder, is that you have to put your d2n over this side, alright, as a matrix, because your this thing over here is a matrix. Gonna multiply by a certain vector, I would say, in terms of the square of the vector. So be kind of careful of that. Alright. Oh, I know why. It's because, alright, this is dc square, this is the x square, while the d2n is, the 2 is inside here, and then your c is outside. Alright, so you're gonna cancel because all the square are outside now. So you cancel, so left with the x square, which is also outside. I think you get what I mean. So be very careful. I repeat again, be very careful of how do you do this, writing in this term. Okay, be very careful. Be. And therefore, just to take note, your Jacobian is dx1 over dc. Alright, this is also being derived in the video, or in l9v8 Jacobian. Okay, so if you happen that you don't understand anything, you can just watch it out. The concepts for this one, although it's for bar, it can be also applied for the beam. It's a general concept for the Jacobian. Alright, so the dx1 over dc is the Jacobian. So if it's 1 over j, is actually is equals to dc over dx1. Alright, so this is, where am I? This is this thing over here, dc over dx1. Alright, is equals to 1 over j. Okay, well, however, we are talking about square, so it's just 1 over j square. This is everything square. Okay, so therefore you have 1 over j square over here, and then, alright, times d square n. This whole stuff over here is your n. Alright, while this other color, d square dc square, is this thing over here, d square dc square. Okay, I hope this is pretty clear. Alright, just if you find that it's very confusing, I'll just remove this thing for a while. So I'm just simply taking this one, I rearrange to become this one. That's all. Okay, so this thing over here is simply this thing, while this thing over here is this one. Okay, while taking note that your n is this whole chunk over here. Okay, I hope that this is pretty clear. Yeah, I'm gonna take this Jacobian thing, I'm gonna bring it all over here. Okay, the reason why, because I want to translate this one into this one. Okay, but taking note that your b, alright, your b can be rewritten as this chunk over here. Very big, right? Okay, your b is over here. Okay, just take note that is equals to this. Your b matrix, I would say, strain displacement matrix. Okay, so we know that j is equals to this one. So j dc, if I were to bring it up, is equals to dx1. Alright, so this dx1 over here, I just simply sub in as j dc. Rearranging again, alright? It's just simple rearrangement. Now I'm gonna copy this B matrix. I'm gonna place it over here. Okay. So it's a hell lot of a rearrangement, alright? Never mind. I find that it's very long. I also don't know what to do. But anyway, this B over here now is this one. Okay. And take note that when you change your Jacobian, your dx1 to your Jacobian times dc, you're gonna integrate from L, the line integral, to the lambda. Alright, the lambda integral. If you still remember, your bar is over here with a certain length, and then you map it to something like this. This is 0, so c is equals to -1, this is c equals to 1, and then this whole length is lambda. Alright, so this is talking about this lambda. Alright, it's the same thing. Alright, it's the same thing. Okay, I didn't cheat your feeling. I just want to let you know that your B matrix over here is can be written as this form over here. Alright, while your D times BT, including your J, wow, okay, nice, can be rewritten as this form over here. Okay, that's why I say I will not prove to you anything, because it's very hairy right now. Okay, so just to take note that this B over here is simply rewritten as this one, while your this thing over here can be rewritten as this one. Your DC is still here. Okay, your DC is still here. Alright, just to let you know is that this one is equals to this one is equals to this one. Just compare a little while, just check it out a little while. This thing, same as this thing. So as you can see, this is in some form of a BT, this is in some form of this is in some form of a B matrix, this is in some form of a BT matrix. Alright, as we have shown you just now, but included with the J and the D. So I say there is many information. I think he just skipped it, and he did the right thing. Alright, because I don't know what the hell. But anyway, let's continue. So now we do a dialectic product. 6 times C multiplied by 6 times C, you will have 36C squared. Alright, and then this one multiplied by this one, you will have this one, and then this one multiplied by the next one, this one is some other forms, and then this one again multiplied by this one, you will have some other forms. Alright, it's a big stuff. Alright, and then you just do all the multiplication and dialectic product. What you have is, I'll paste it over here. Okay, this is your K matrix. Alright, just simply pasting your K matrix, because we sub in your B's, right? So this is still your K matrix over here. So I take this whole chunk, I copy, and then I'm gonna paste it all over here. Right, the same thing. I didn't cheat your feeling. Okay, that's the double check. Alright, so let's continue now. Alright, because I don't want to show you all the stuff. The matrices, all the derivations are all here, but I'll just skip. Okay, as you know, I've shown you that the matrix multiplications already. It's just the multiplications only, and rearranging a lot of stuff. You will have this form. Alright, minus this form. So it's a minus over here. Alright, it's still kind of hairy. At least you get to see certain form coming up. Alright, I'm not going to derive this. So 12 minus 12, you will have 24. Same thing, you do the matrix subtraction addition, you will get all this stuff. Alright, 3L minus 9L, you will have 12L. I think the rest you know already is the same. Alright, and therefore this thing over here, okay, or simply the matrix over here is simply this one minus this one. Now let's take a look in terms of the coefficient, this one and this one. Okay, as you will compare, they have actually changed. The coefficient has changed a little while. Alright, because the J itself, if you remember, the J is equals to dx over dc is equals to length over 2. Alright, meaning this is the bar of the length. This is taking back the same assumptions from the Jacobian. So therefore, I will highly suggest that you watch the Jacobian. Watch this video on l9v8, the Jacobian. You'll get to know that why is it L over 2. Why is L over 2? Because if you were to map it to this system over here, okay, each of this I forget already, we know that lambda is equals to 2 lah, okay, so this is 2 because this is 0, this is c is equals to minus 1, c is equals to 1. Alright, so at this portion over here, c is equals to minus 1, this portion over here, c is equals to 1. So the overall length is equals to 2. So therefore, this one is equals to 2. That's why I say, yeah. But anyway, at least you get a feel of it lah. Right? You get a little kick with it. Alright. So therefore, this thing over here, you know that j is equals to L over 2. So j cube, as you can see, j cube over here is just cube 1 over. Alright, because this is this is j ma. Alright. Is it? Yeah. This whole thing over here is 1 over j cube. So therefore, I'm just simply rewriting this only. Alright. So if I were to elaborate, I'll have 1 over L cube divided by 8. Alright, 2 to the power of cube is 8. Alright. So just simply rearrange, I will have equals to 8 over L cube. Alright. So this thing over here can be sub in into my j cube. So instead of j cube, I'll write it in terms of 8 over L cube. Maybe I should write in the bigger word. 8 over L cube. Alright, as you can see, we can cancel 8 and 16, we have 2. Therefore, we have d over 2 times L cube. Alright. So I think it's kind of straightforward already for you, right? So I'll just cancel, this is 2. So I have d 2L cube, which is this one. Okay, we are almost there, hang on. And I simplify because I see 24, 12, 8 all have the same common term of 4. So I factorize out 4. So I have 4 over here. Okay, so for example, if I factorize out 4, hold on. If I factorize out this thing with 4, I'll have 4 times all this. Okay, so it's just 4, so I'll just bring this, because 4 times, so 4 times d also, right? So I'll just bring this 4 to the side together. So 4 and 2 cancel, I have 2. Sorry, I have 2 over here, 2d over L cube. Okay, so therefore I have 2v over L cube, this thing over here. Okay, and therefore the general equation for our stiffness matrix is this one, 2d over L cube, this thing over here. Okay, so therefore this is for your beam stiffness matrix. Alright, so before I go, I just want to convey the key concepts also, is that for in this case right here, with this after you found your PVD, alright, then you're gonna know that you're gonna do something with your strain displacement matrix B. Okay, next you're gonna also deal with the J. So the key things to identify is your B and your J, your Jacobian. Okay, and also the concept of rearranging your J in terms of dx is equals to J times, you just bring this up over here. Alright, with a certain other understandings of taking that J is equals to L over 2. Okay, J is always, I believe up to now, J is equals to L over 2. Alright, then you can sub in all the stuff already. So these are all the little stuff that you need to know for deriving this thing. Alright, especially coming from this equation now. Alright, I repeat again, this comes from the PVD. You can also derive it for the bar coming from the Wigform-Gilligan's method, or also coming from the PVD also. We have proved to you all many of them. And therefore I shall see you soon.